This tutorial will cover adding flat buttons to the game to change the animation direction. I'm going to create some flat buttons so that we can interact with the flat display. Right. Let's first make the function that we're going to call with the button. We're returning a stack right now, right here for the background, but I'm going to return a column. fd.column. I'm going to set some controls for the column. The list. And above the stack, I'm going to create a row for my button. In the button controls, fd.button. Make a right button first, and on click will be equal to on right click. All right, so we'll create the rest of them. On left click, we have our four functions that will change the direction. Now we can create the 4 buttons, 3 more. On up click, and down on down click. And we'll set the row alignment to center. Alignment equals FD dot main axis alignment dot center. Okay, let's see what it looks like. Nice, nice. Okay, these don't work right now because there's no left. There's only the case for right. We have to add the left frames. Also add all of them. Left. 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 And this will be up frames. Up frames. Up one. Up two. Up three. This will be down frames. Down one. Down two. Down three. All right, let's try to create the case for left. Let's copy the right. Will be the case. We'll change it from right to left. Current state frame will be left. We'll change the current frame to left. And this will be the length of the left frames, although they're all 3. And make it move, we just want to make sure that it's greater than 0, which is the left side of the screen. And instead of plus, we're going the other way, so it'll be minus. And in the frames here, we will copy this, change it to left. Left. Guess I just copy the frames. This would be right, so this would be up. And we'll have one from down. Okay, let's test it again. moving to the right. Now he's moving to the left. And it's looking good. Buttons. Probably switch the order. He's moving to the right, moving to the left. Stops, or she stops. Good, good. Okay, we don't have this working yet. Let's add the movement for up and down. So the down will be very similar to this. We'll copy it. We'll paste it, but we'll switch it to down. And this will be down. Current frame will be down. It'll be the length of the down frames. And the sprite Y, the height of the screen will be 600 that we specified. And the height of the character is 120. And then we will top is 0 and the bottom is the biggest number. Try it out. Restart it. It's great. It will put in the up. And in this case, we have almost everything set up and wired up. Up. Current frame, up, up. This is up. It's the length of the up frames. And it's the top head. So her head's at spread sprite Y 0. We will then move her up. Left, going right, left, up. She's going to stop. Boom, she stopped. Go down. She stops. Congratulations on finishing your app to this point. You have some great state management using a declarative UI, and you've also implemented MVC architecture, model view controller. So there's 3 parts to the application from an architectural standpoint. The model, which holds the data and business logic, the view, which is largely the user interface, and the controller, which handles the user input and coordinates the model and view. So we have our project. In the project root, there's a folder called model. And in that folder, there is a file called game_state. This holds the model, and it is a game state class. It's a standard Python class, but we've added some decorators onto it. There's another folder that's called view, and in the view folder, there is a file called game.py. And in here, there is a game view component that we created. The final folder of the MVC organization is the control. And in here, we have a movement.py. and it updates the sprite functions. The model does not connect directly to the UI. It doesn't know about the UI. And the view should know nothing about the business logic. The controller should be able to coordinate between them. Our model, which is called game state, we have some information about the state of the game, particularly the character Pepper, where the direction is right. The sprite X has a value of 5 and the sprite Y 300. Also the current frame of the animation and the direction. If organized correctly, the model should only be responsible for storing the data, the application data, the data structure, the business logic methods, but no UI code. The view should contain the UI components. We have the column, we have the controls for the individual buttons to click on, and we have the sprite. Ideally, the view should display the data from the model. It can read in the data from the model, and it will represent it as a UI, in this case, graphical characters. The view also handles the user interactions, clicks, so your buttons, other types of input. Will send user actions to the controller, but it should ideally not have business logic. And these aren't like really hard and fast rules. This is just a easier way for you to organize. The controller there, we have a folder called control, and there's a file called movement.py in there. And in this movement.py, we have the game logic for how to move the sprite based on the different directions. The controller should process user actions, update the models based on the business rules that we have set up, coordinates between the model and the view, but there should be ideally no direct UI manipulation within the controller. In the MVC data flow, so you have your application, the person clicks on a button, let's say the left button. In the view, there's a on left click handler. There's a function here which goes to the controller, updates the sprite state, goes to the model. It'll set the state dot direction using the observable to left. So at this point, it's going to kick into the observable and automatically force the re-render. MVC, you have the separation of concerns. It's easier to test each layer independently, and you can modify one layer without affecting the other layer too much. So now you can make your application more complex, add more characters, maybe some actors, such as a cupcake or some other food for Pepper to interact with, or maybe even bring in Carrot the cat. Have fun as you're experimenting with Flet and Python.